Linux is a common skill for DevOps, but how do you actually learn it? So I'm a big fan of context-based learning, meaning that you learn something because it will solve a problem in some other area of your life. For example, if you want to learn to ride a bike, you can watch YouTube videos all day long and make no progress. And the same is true for learning technology. You need a goal. For riding a bike, your goal might be to ride your bike to the neighborhood store and buy some ice cream. That's a measurable goal, and anything that gets you closer to the store on your bike counts as progress. So for now, your goal is not to learn Linux. Your goal is to launch my website. So let's do this. Hey, I'm Will Button, and this is DevOps for Developers, where I teach you the skills that you need to build faster and safer using DevOps principles. So I get it. We're not really going to build our own Linux server to run a simple HTML website. There are just too many better options for that, ranging from using an S3 bucket in AWS to Cloudflare Pages. But we do want to use this as an opportunity to build our Linux skills because, as you know, the whole world runs on Linux, and having some insight into how that works gives you the foundational knowledge you need to make higher level decisions. It's a lot like when your car makes a weird noise. Knowing a little bit about how your car works allows you to determine if that was a noise that can be ignored or if it's a pull off the road and get out of the vehicle noise. Let's start by getting to some common understanding on what I mean when I say build a Linux server. So a Linux server is just a computer, just like the one you're watching this video on, whether you're using your phone, your laptop, or a desktop computer. The difference is who the end user is. For your phone and a laptop, the end user is a human, so the interface reflects that. There's windows and boxes and things to click on that make using it easier. For a server, the end user is other servers. And in our example, the end user is going to be another computer that's requesting the contents of my website. As a result, servers typically don't have a user interface. They don't need one. They do have a terminal or a shell so that the humans can configure the server, but that's simply just a byproduct of the current limitations. So in summary, when I say Linux server or server, it's really just another computer. The first thing we need is a place to run our Linux server, and we've got a lot of options available to us. If you have an old computer that you aren't using, it's a perfect candidate. No matter how old or out of date it is, as long as the hardware works, I can guarantee that you can run Linux on it. Another option is one of these, a Raspberry Pi. You can pick these up at pretty reasonable prices and you can install Linux on it. One of the benefits of this approach is you have the physical server right in your hands so that you can focus on learning Linux versus learning about Linux in a hosted or cloud provider environment like AWS or GCP or whatever. You can also use a software program like VirtualBox that allows you to build virtual computers on your existing laptop or desktop. You'll get the hang of it pretty quickly. Plus, you don't do anything that might jeopardize or render your current computer inoperable. And when you're done, you can just delete the virtual server. And that sets the stage for your next option because virtual servers are probably going to be your primary tool for the next few years. And you can use AWS, GCP, or Azure to launch a virtual server in the cloud. This is probably the most complex way to do this because you'll not only be learning Linux, but also how to interact with the cloud provider as well. Plus, there's a potential here to spend money that you don't really want to spend by launching something on the cloud and either not realizing how expensive it is or forgetting about it until they charge your credit card. The next step is to actually install the Linux operating system, and you've got several options available, pretty much like all the steps that we're going to go through here. In the Linux world, these options are known as distributions. So Linux is the operating system, but there are multiple distributions. Think of it like a t-shirt. There are many t-shirts in the world, but Some may come from different manufacturers. In the Linux world, the most common distributions are Red Hat, Debian, and Ubuntu. And I'm going to recommend that you start with Ubuntu, but you're going to want to learn Red Hat and Debian over time. For what it's worth, Ubuntu is based on Debian, so many of the skills you learn in Ubuntu will translate directly to Debian. Here's the deal though. All right, I am not going to tell you how to install the operating system in this video, and I've got a pretty good reason for doing that, or not doing that. Look, there's tons of great resources that already do that. From the documentation provided by the Linux distribution that you're using, to tutorials, to videos and articles, there's not really anything I can say that hasn't already been said. Also, more importantly, by forcing you to go find that information for yourself, I'm actually helping you to build the most critical skill that you're going to use in your career, and that's finding information. Look, if you worked at a grocery store, a large part of your day would be filled with customers coming up and asking where something is at in the store, and you would tell them what aisle they can find that product on, right? In our world, though, it's rare that we do something so frequently that it becomes routine for us, which means we spend a lot of time trying to figure out how the problem being described to us translates into the real-world mechanics of operating servers. To put this in perspective, your customer, which is me because we're building my website, wants a website hosted on the internet, so the task is to break that down into the components needed to make that happen and create a series of tasks to build or create those components. Understanding how Linux works gives you the foundation to understand the components that are needed and the ability to reason about why things are working and why they may not be when things go wrong, because they will. That's why Linux is still important to learn, even if you choose a hosting provider rather than building your own Linux server. The last step in installing your operating system is to create your own user account. You've probably been using a user named root up to this point, and it's a user that's present on every Linux system everywhere, and it always has a user ID of 0. It's kind of unique because it's the master user, the one who can do anything, the one that never gets told no, or one account to rule them all, if you'll humor me on that. Which is cool, but it's also very powerful. As a result, we don't want to be that user. We don't want that much power unless we know that we absolutely need it. So instead, we're going to create a user account for yourself, and that's the one you're going to log in as, but you'll give yourself sudo permissions, meaning that if you need to run a command using the elevated permissions available to the root user, you can preface your command with the word sudo, which will run your command as if the root user had done it. A little bit of random trivia here. Sudo actually stands for super user do, as in, hey, super user, do this thing. All right, once you have your Linux server up and running, got your user account created, you need to tell it how to host a website. If you're not familiar with the mechanics of how that works, our server is going to listen on its IP address for requests on TCP ports 80 and 443. So if the terms IP address and TCP ports are new to you, this is a good spot for you to add networking to your to-do list. So on your desktop or your laptop, if you wanted to browse the internet or a specific website, you would use a browser like Chrome, Brave, Opera, Firefox, or whatever. On our server, we want to actually be the internet, and there's software available to help us do that, just like you would use a browser to do a certain task on your desktop computer. Two of the most common packages for hosting static HTML websites like ours are Apache Web Server and Nginx. I'm going to recommend that you use Nginx because it's probably the one that you're going to encounter most often in your career. You don't typically see Apache very often anymore. But installing it is fairly easy. It's a couple of commands that you type in, but there's one thing I want to highlight here because it's a common misunderstanding I've seen over the years. Your operating system comes with its own repository of software you can use. If you type apt-get install nginx, you're going to get the version of nginx packaged with your operating system. If you go to the nginx website though, you'll see that they recommend you install their repository on your system and install their version of nginx. So that's probably got you asking,
What's the difference between them?
well, let me tell you. The repository installed with your operating system comes, not surprisingly, from the maintainers of that operating system. The software that it has available to it in that repository has been vetted, tested, and it's guaranteed to be compatible with your operating system. But because there are so many different applications available, it's probably not the latest version from the team over at nginx. So if you want the latest version, you can install the repository from nginx and get the latest version from them. But there is a trade-off. First of all, I really want to clarify, you can have multiple repositories on your server. That's not an issue at all. If you add the repository from nginx, it's only going to be responsible for installing and updating the nginx application. It won't try to install packages that it isn't responsible for, assuming that it's a legitimate repository. If it's a malicious repository, it could very well install software that hijacks and compromises your computers. So, only add repositories from trusted sources. The next thing I want to point out is the responsibility. All right. When the maintainers of the operating system add a package to their list, they are guaranteeing that it is compatible with your version of their operating system. When you add a repository from a third party, that may not be the case. They put in a lot of effort to ensure it's going to work, but their job is to ship the latest version of their application, not to guarantee compatibility across all versions of all operating systems. So as a result, when you're thinking about adding a new repository, ask yourself, do you want the most stable version available for your operating system, or do you want the latest version available? And if you have to do some extra work to ensure compatibility, then that's worth the risk to you. Once you have your answer, either install nginx from the default repository already on your server, or add the repository from nginx and install it from there. At this point, now we've got our server built and we've got nginx installed, but it doesn't know how to serve up our website, so we need to configure it to do that. The first step is to get our website files onto that server, and I'm going to suggest that you use SCP to do that. And the reason is that in your career, it's going to be rare that you have physical access to the server. So copy paste, shared directories, or putting the files on a USB stick aren't options that will be available to you, but SCP always is. To get that to work though, I'm going to have to send you off on another quest. SCP uses SSH to copy files. SSH requires that you generate private and public SSH keys on your desktop computer and then add your public SSH key to your server so that when you SSH using your private key, it can verify that you are who you say you are against the public key that it's been given. When you SCP those files over, they're going to go into your home directory. That's kind of like well, you probably know what a home directory is. You've got one on your computer. But here's the deal. That's not where nginx is going to look for content. So you need to figure out where that is and then get your files over there. And don't forget to check the permissions on the files to verify that the nginx process is able to read them. And this is a good time to talk about the config file for nginx too. Most Linux applications use config files to control their behavior and operating parameters, and it's common for these to live in the /etc folder on your file system. There are also permissions so that not everyone can write to them, so you'll need to use your elevated permissions, the sudo command we talked about a little bit earlier, to make the changes to them. Spend some time getting familiar with not only the nginx config file, but the etc directory in general, and the various tools that you use to interact with that. This can be things like the cat command to print the file out to the terminal. You might combine that with the grep command to find a specific word or phrase, and you can use less to view the file in an interactive pager that lets you scroll up and down through it. And you'll also need to learn how to use Vim for editing. And you can also use Nano for editing, but if you're called on to edit a file during an interview or a demonstration, using Vim is instant credibility, so it's kind of worth the effort that it takes to learn it. All right, our next series of tasks in launching our website is to learn about the operational side of it. Some questions that may be running through your mind at this point could be like,
Wait, so is it working now? And if so, how do I view this website? Or even like, what if something goes wrong? What do I do then?
and those are all really good questions. So I'm going to give you some hints on how to tackle them. If you haven't made the connection yet, Nginx is installed and configured, though we don't really know if it's configured correctly, but it can't respond to requests for our website until the Nginx application is running. Now, on your desktop or your laptop to run an application, you double click an icon, but on servers, there's no icons, right? And one important concept to grasp is we absolutely can type the Nginx command at our terminal prompt and Nginx will probably work. But as soon as we exit that terminal, Nginx will stop working because we aren't logged in anymore. So any website has to have 24/7 availability. So it's not feasible to stay logged into our server forever, right? It's tempting, though, to launch the program as a background task, but that's got some problems too, because ultimately you're going to be working with a whole team of people, any one of which could launch the Nginx program in the background. But now, when something goes wrong or it needs to be updated, the question becomes,
Wait, who launched Nginx?
and now the race is on to figure that out. And that's just a lot of wasted time and effort. So that's not a very clean solution either, right? What you're really searching for at this point is a centralized managed solution for running server tasks that should always be running. The people who made Linux have already thought of that for you, and they've delivered it in the form of a stack of applications called systemd. Systemd provides a set of commands that let us start, stop, and check the status of Nginx. In our case, it's probably stopped right now, so our first task is to start it. And now, because systemd is managing that process, when we log out, Nginx is going to stay running. And if by chance there's an error in our Nginx config that prevents Nginx from starting, systemd also provides us with a command to get the logs from the Nginx process, and that may be useful in troubleshooting our configuration. There are some additional logs that you should be looking for too, because ultimately, our goal is to have millions of people viewing my website. And we're going to want to track how many people are accessing my website over time. We also want to know how quickly my website is loading because I want to make sure that it loads quickly and the users of the website are seeing the content quickly, because few things are more frustrating than waiting for a website to load. We're also going to need to check for error pages on the website to find out if users are looking for a page that doesn't exist or if the server is throwing errors that we should probably fix. None of the logs to answer these questions can be found with systemd. That's for the Nginx process only. To answer all these questions, we need to see the logs that Nginx writes itself, and those can be found in the /var/log directory. So go ahead and head over there, find your Nginx logs, and use your Linux commands to view and read these log files. One thing I'll point out while you're doing that is these log files follow a very specific format. Nginx calls their format the combined log format, and each row in the log file presents the exact same information in the exact same order. This makes it really easy to send your logs to a centralized log server and create dashboards, monitors, alerts, and so on. Well, right now, your log file may be looking pretty empty because no one is actually viewing the website, but we can fix that. The quickest way to test things out is to use the curl command on your terminal. So your next task is now to learn how to use the curl command, and I'll give you a little hint here. When you're logged into your web server and you want to view the web content that it provides, you can refer to it as localhost. The localhost word or address is a shortcut that tells the computer the content you want is on the same computer where you're running that command, versus some other server out on the internet that you would have to specify by IP address or DNS name. Once you successfully get the contents of your website using curl, check your web server logs again, and you should see the log entries for each time you use the curl command. Spend a little bit of time here to learn what each data point in the log represents so that later you can use this information to rationalize what may be going on when your server has thousands or millions of viewers. Now, if all has gone well up to this point, you should be able to view my website locally and from your desktop or laptop using your browser and pointing it to the IP address of your server. A couple of other tasks you can do that are worth your time and effort are to use the top command and investigate everything that you see on the screen. Dig around, find out what all those things are because they're all pretty meaningful. There's a lot, but it's worth your time and effort. It's also a good idea to use the netstat command and see if you can figure out what TCP ports and PID or process ID Nginx is using. This is actually pretty common when you're troubleshooting networking issues. So as we wrap this up, in reality, we've only scratched the surface of Linux. But if you made it this far, dude, give yourself a big pat on the back because by working through this, you started building your foundational knowledge of Linux. You've learned how applications are commonly configured, and you've learned some of the troubleshooting and monitoring tools that you're going to use every single day for the rest of your career. As I stated in the beginning of this video, the tools available to us today abstract a lot of this away to the point that you'll probably never actually host a website like this using Nginx, but it hasn't been a wasted effort. You will use Nginx for other purposes in your career, and also all of the tools you use to host a static website are doing some variation of this same process. So by understanding how it works under the hood, when things go wrong, you know kind of what's happening and you can make intelligent progress on resolving that issue. You'll also use these same skills for running other applications on Linux as well. So we did a lot of cross-functional skill building in this video. Now, if you want the transcript of this video, in addition to the static website that you can deploy as you follow along, head over to devopsfordevelopers.io/Linux, and I'll send it to you along with my DevOps roadmap, the Choose Your Own Adventure guide for building DevOps skills. If this has been helpful to you, it would really be helpful for me if you shared the video with someone else that it might help. And don't forget to hit the subscribe button so you don't miss future videos from me. And thanks for watching, and I'll see you in the next video.